that you're aware. So we're going to be talking about the properties of matter. We've discussed the different types of matter, elements, compounds, our two types of mixtures. So today we're going to talk about how we describe that matter. So a property is just any characteristic that can be observed about a substance. So it's green in color, or it reacts with oxygen, or it's flammable, or it tastes sour. Okay? So those are all properties, just a characteristic of any substance. So there are two kinds we're talking about, physical properties and then chemical properties. Okay, so a physical property is observed using your senses. So using sight, touch, taste, hearing possibly. And you can determine or observe the physical property without destroying the matter. So if I have a calculator here, I can observe that it's blue in color without changing what it is. It's still a calculator even though I've observed its property. So any of those are examples of physical properties. So it's luster. Anyone know what luster is?
Is it like something that shines?
Yep. So like metals have a high luster, they're very shiny. Okay, opposite of luster would be something that's dull. Okay, you can observe color, you can observe odor. What about malleability? What's malleability? Something is malleable. How would you describe that? So it bends. So like metals are very malleable. You can bend them, shape them into different things. Okay, you can observe something's magnetic. You can observe if it conducts electricity. You can observe melting and boiling points, density, mass, weight, volume, length, hardness, and taste without changing the substance. So it still stays the same thing. So you want to write down a few of those examples there. So anything you can observe without changing what it is. Okay, so then we have our chemical properties. So they are going to indicate how a substance is going to react with another substance. And so to observe a chemical property, you have to change the substance. It has to go through a reaction. So you start with one thing, you end up with a new substance after you've observed it. So examples include, does it react with an acid? Does it react with a base? Does it support combustion? Is it flammable? So in order to know if a liquid is going to be flammable, you have to ignite it on fire. And that's going to change it into something new. You could also observe, does it decompose? Does it corrode or rust with iron or does it corrode like iron does and turns into rust? Does it react with water? Or does it react with the air around us? So in order to observe a chemical property, you have to change it into something new. Okay, so we can also change these properties now that we know what the properties are, so we can actually go through a change. It's a little late. So we're going to talk about physical changes. So physical change is a change in an object's or substance's size, shape, or state. But again, by making that change, no new substance is formed. So I could take a piece of paper, and it has a certain volume and a certain mass, okay? And I could cut it in half, and I've changed its physical property now. So it's gone through a chemical change. Or a physical change, sorry. So it's still paper, now it's just smaller. So that would be a physical change. Or you can talk about like painting a fence. Your fence was white and now you paint it red. It's still a fence, now has changed one of its properties. So it's gone through a physical change. So a physical change could include a change in texture, a change in shape, size, color, odor, volume. Right? If you spray perfume on yourself or your cologne, it's still you, still the cologne, now it just has a different odor to it. So physical change, you change a physical property, but it stays the same substance. Okay? So an example of a physical change would be like taking water and freezing it. It's still H2O liquid, H2O solid. We haven't changed what it's made up of. Still 2 hydrogens to 1 oxygen. It's just now in a different state. Okay? So a chemical change, you're going to change both your physical and a chemical property. And you're going to form something completely new. So a new substance. So cooking an egg, it changes from a clear color to a white color. So you're actually changing or denaturing the proteins in that egg. So it changes into something new, a different substance. Or burning logs on a fire as a chemical change. So you're taking wood, which is a combination of hydrogen, oxygen, and carbon. You're going through a combustion reaction. You produce a gas, CO2 gas, you produce heat, and you're left behind with this black-looking stuff. And that is just pure carbon, soot. Or metal rusting. So iron reacts with water or moisture in the air, and it turns from iron, just Fe, to iron oxide, which has the orange-looking color to it. So next week when we do a lab on chemical and physical changes, you're going to look for these 4 clues. So these are the 4 clues that will tell us if a chemical change has occurred. So does it change its color? Does it produce a gas? So a lot of times you'll see, like when you're burning logs, you're producing CO2 gas. You see it as smoke. Or sometimes your solutions will start to bubble or fizz. That means it's producing a gas. It could change in energy. So it could get really hot, meaning it's giving off heat. Or it could start to feel cold to you, meaning it's taking in heat. Or number 4, you produce a precipitate. So precipitate is a solid. So you mix 2 liquids together, and all of a sudden you see the solid start to fall towards the bottom. So that would be a precipitate. The only one you have to be careful with is number 1. So remember, painting a fence is still a physical change. It hasn't changed chemically. So sometimes color change does not indicate a chemical change. So that's one you got to be careful with. So here's kind of the difference between the two. So if we take water and we freeze it, it's still water. H2O, H2O, just a different state. But if we take water and we add another hydrogen to it, or another oxygen to it, we create hydrogen peroxide, which has totally different chemical and physical properties than water. So you make something new in a chemical change. So let's go through and see if you can guess whether these are going to be physical or chemical. So I want you to write down your guess, and then we'll go back through and go through the answers. So number 1, sugar dissolves in tea. So is that a chemical change? You can write a C on your notes, or a P for physical. For a chemical, you make something completely new. Physical, it stays the same substance. Okay, number 2, burning logs on a fire. Is that chemical or physical? So put down your guess. 3, breaking water up by separating it into hydrogen and oxygen. So chemical or physical. Number 4, cutting a piece of paper. Number 5, crushing an aspirin. Six, metal rusting. 7, lighter fluid burning. 8, an egg rotting. And the last one, number 9, an egg breaking. Okay, so number 1, what did we say? Sugar dissolves in tea. What was our guess?
Physical?
Physical. Yep, it's still tea, it's still water, it's still sugar. They're just now mixed together. So that would be a physical change. Okay, what about logs burning?
Chemical.
Chemical. We produced something new. We gave off heat, we gave off a gas, we changed color so it looks black now. We produced a new substance. Okay, what about separating water into hydrogen and oxygen?
Physical? No.
Nope, so that one's going to be chemical. So it's actually a reaction. So we take water, H2O, and it decomposes into hydrogen and oxygen gases. So hydrogen gas is very flammable. Oxygen gas is not, obviously not, but it changes properties. Okay, what about cutting paper?
Physical.
Physical, still paper, just now smaller size. Okay, what about crushing an aspirin?
Physical.
Physical, still an aspirin, just now in smaller pieces. Metal rusting.
Chemical.
Chemical, so you produce a new substance and it changes color. So that iron oxide is that orange color. So something similar would be like your silverware. If you have like really nice silverware at home that's actually silver, over time it tarnishes and it gets these black spots on it. So that's a new substance that's reacting with. What about lighter fluid burning? Chemical. So our clue is it gives off heat, gives off a gas. What about an egg rotting?
Oh, that was chemical.
So it's going to be chemical. We're actually producing a new substance, and that new substance, so eggs produce a sulfur compound, and so that rotting egg smell is that new substance, that's sulfur. So any food like spoiling, you're producing a new substance. So that's why it tastes bad to you. What about an egg breaking? Last one. Physical. Still an egg, now just in different pieces. Good.